In this section, we're going to look at perfect square trinomials and differences of squares and how to factor them based on patterns. The patterns that you may observe are related to the first and last term and how the product can be combined with 2 to make the middle term. Now, once you identify this pattern, the factoring process will be very, very easy. The hard part is identifying the pattern. So that's why we're focusing on that in this video. When you're looking at perfect square trinomials, you'll notice that the first term is always a perfect square, the last term is always a perfect square, and the middle term is always the product of the 2 bases, if they were exponentiated, and that product multiplied by 2. So as you can see, some examples of this would be x squared, that has a base of x, and 10x, we'll talk about that in a minute, plus 25. Notice 25 is a perfect square as well. Whenever you see a perfect square on the first term and a perfect square on the last term, it is very likely a perfect square trinomial. There is a very, very good chance that it will factor to 2 identical binomials. And if you notice that they are identical binomials, make sure you write them as a more compact factored form, which is the x plus 5 raised to the second power. We can see this again with x squared minus 8x plus 16. X squared is a perfect square, 16 is a perfect square of 4. And so if you look at the binomials, you can see that once again, they are identical. The only reason it's a minus instead of a plus here is because the second term, negative 8x, is a negative 8x instead of a positive 8x. Again, if you look at 4x squared plus 12x plus 9, we have 4x squared and 9, which are both perfect squares. If I were to write what that would look like if I just had my base raised to the second power, that would be 2x all raised to the second power. That's a perfect square trinomial. First term. And 9 would be 3 squared. So when I say the bases, you're looking at those bases multiplied to themselves. What do they get? All right, hopefully this makes some sense. Now let's talk about the patterns. I've already showed you the patterns and what to look for, but this is the formal way to look for it. The first and last terms must be squares. We call them a squared and b squared just because it's easier to talk about it with patterns. There must be no minus sign between the first or last term. So a squared can't be negative and b squared can't be negative. The remaining term, the middle one, must be plus or minus 2ab. And so that's why it's very important to be able to identify your base a and your base b before you look at the product in the middle. So the 2 patterns you will see for perfect square trinomials are a squared plus 2ab plus b squared and a squared minus 2ab plus b squared. And your binomial squares will look like a plus b squared or a minus b squared, respectively. So let's determine whether each polynomial is a perfect square trinomial. X squared plus 14x plus 49 has a perfect square as the first term, and 49 is a perfect square of 7. So I just look at my signs, and since the middle term is positive, I know that I'm going to have a plus plus. So yes, first trinomial is a perfect square trinomial. Now let's look at the second. Notice that it is not in descending order of exponents, in which case we need to rewrite it that way. That gives me 3x squared plus 4x plus 16. 16 is a perfect square, but 3 is not, and so this is not a perfect square trinomial. In this last example, we have 100y squared minus 180y plus 81. And if we were to look at the first term and the last term, 100y squared is a perfect square of 10y. And 81 is a perfect square of 9. So yes, this one does appear to be a perfect square. The only thing is to check that if I were to multiply 10y to 9 and then multiply that by 2, would I get the middle term? And yeah, you do. So that gives me 10y and 9, 10y and 9. The middle term is negative. And so the middle terms on both my binomial factors will also be negative. So yes, this one does pass the perfect square trinomial pattern test. For exercise 2, we want to factor the remaining expressions completely. So I'm just going to read them off and then factor them and tell you what the factors are. But you should really, at this point, review the pattern, pause the video, and try this on your own. These go really fast once you see the pattern. So go ahead and try that and then come back and check your work. Welcome back. On this first one, we have x squared minus 18x plus 81. X squared and 81 are perfect squares. So I'll have an x and a 9 and a 9. The middle term is negative, so both my binomial second terms will be negative. And I will rewrite this as x minus 9 quantity squared. In part B, I have 16y squared plus 49 plus 56y. I'm going to rewrite this in a different order. 16y squared plus 56y plus 49. Now it's in descending order of exponents. I'll factor it because 16 and 49 are both perfect squares. So I'll have a 4y and a 4y. That'll give me 16y squared. And 7 and 7. That will give me the 49. Since the middle term is positive, I will use positive signs in between. So my perfect square trinomial factors to 4y plus 7 quantity squared. On my next trinomial, I have 25x squared minus 20xy plus 4y squared. The first and last terms are perfect squares, so I'll have a 5x and a 5x as my first term in the binomials, and 2y and 2y as the second term in my binomials. Since the middle term is negative, I will put a negative in between my binomials. So my final factorization is 5x minus 2y quantity squared. In part D, I have the expression 2x squared minus 40x plus 200. I'm going to factor out a 2. That gives me an x squared minus 20x plus 100. Now it does appear to have a perfect square pattern to it, so I just leave that 2 out front. And factoring, I get x and an x, a 10 and a 10. Since the middle term is negative, I'll have 2 minus signs on my 10s. And this final answer, simplified, is 2 times x minus 10 quantity squared. Lastly, we have 98p cubed minus 168p squared q plus 72pq squared. Now, we have to make sure that our p's are in descending order and our q's are in ascending order. And if you're dyslexic, oh boy, maybe write them as capital P and capital Q so that it's easier for you to distinguish the two letters. Now let's just double check that we don't need to factor anything out. We actually do. We need to factor out a P. That's common to all three terms. And it also looks like 2 is a common factor. So if I divide out 2 and P, I'll have 45 plus 4, that'll be 49 P squared. And then 168 divided by 2 would be a 50, a 30, and a 4. So 84 PQ. And then 72 divided by 2 would give me 36 and Q squared. Now I'm going to factor my perfect square trinomial. I'll have a 7p for both my first terms of the binomials, and I'll have a 6q as the second term of my binomials. Since the middle term is negative, both my binomial second terms will be negative. Don't forget to drop down the 2p, and you'll be left with a simplified factorization 2p times 7p minus 6q quantity squared.